Okay, we're going to get started. We know that we're going to have some late arrivals, but there's some seats over here. And tonight we have a double header again, and we're going to start off with Jamie Austin. And I'm going to be very brief with my introductions because you guys have bios. Jamie is a senior research scientist at the University of Texas in Austin. He got his BA from Amherst College in Massachusetts and a PhD through the Woods Hole Oceanographic MIT joint program. He's a geophysicist by training, done a lot of very important work, but he's going to talk to you tonight about exploration. And both of our speakers tonight are on what's called the Ocean Exploration Advisory Board. It's a FACA committee. FACA means Federal Advisory Committee Act. These are very important committees, and they advise the leadership of NOAA on what ocean exploration should be like in this country in the very near future. So if everything goes south, these are two of the people that we need to blame.
What an introduction.
And also at the end, if you want to have a copy of a paper, Ocean Exploration Past, Present, and Future by Bob Ballard, I think I have enough up front. We'll do that either at the break or at the end. All right.
Thank you very much. I was given the title by Jerry, right? So when he asked me to do this about 6-8 months ago, it's not often you get a chance to go, the importance of ocean exploration to the nation. So that's going to color what I say to you. Amanda's an ecologist and I'm a geologist, so my inclination would have been to spend more time probably talking about the geology side of the equation and let Amanda talk about the biology, but instead I'm going to high grade this a little bit, and that's a picture of me in front of one of the ROVs in the Oceanus Explorer. It's on one of my better days. I wasn't smiling all the time. I've gotten into ocean exploration in a backward kind of way. I got a PhD at Woods Hole Oceanographic Institution, but I was a geologist. I came from land geology. I was banging on rocks, got into ocean science as a graduate student, but then I'm an acoustician. I'm a seismologist. So I look at the seafloor and the subsea floor primarily using sound and scientific ocean drilling. I've been the director of the drilling program a couple of times over the last 20 years. But I walked into Woods Hole the summer of '74, and this blur went by me in a Navy commander's suit. It was Ballard. He was a graduate student at Rhode Island, but he was a lieutenant commander on handling the Alvin program at Woods Hole. So I was a brand new graduate student. He was finishing up as a graduate student at Rhode Island, and it was really fate. So we became pretty good friends. We had the same advisor, an old Basque Spaniard named Elithar Uchupi, and we became friends, but he went off to do human-occupied vehicle work with the Alvin, did famous work, literally famous work in '74 and beyond, came around to remotely operated vehicle work after doing many, many years of human work, human eyes on the seafloor work with Alvin. And we rendezvoused again at the beginning of the Ocean Exploration Advisory Working Group, which was the precursor to the OEAB in 2004. So I was asked by Bob to be a member of that advisory group. I had no prior experience with the National Oceanic and Atmospheric Administration, but I was an old ocean hand. And Bob likes old ocean hands because he's an old ocean hand. So in every profession, there is the old boy or old boy and old woman network. It's true everywhere and in every profession, and that was how I got into ocean exploration. Now I've been doing narrations for ROV dives for about 5 years. And by the way, as I go through this, please ask questions. We've got enough time. I'd rather have you interrupt me. This is a kind of a video clip heavy talk. So some of these clips have got narration attached to them, some don't. But please just pipe up and ask. This is a kind of an interactive thing. I'd rather have you do that than have you store them all up when I'm tired and try to ask them at the end of the talk. And I am absolutely going to be done at 5 minutes to 8. Because then Amanda takes over, and you all have to be out of here by 9:15, and we have to sign autographs and things like that. So what I wanted to do, because what I learned early on in ocean exploration is that if you're going to narrate over the web, you've got to have a voice. that works for people, not just for yourself and not for your scientific colleagues, but for all of those players out there that want to try to understand what you're looking at. Ocean exploration of the seafloor is a visual business. Well, visual is easy if you understand what you're looking at. Visual is pretty complicated if you don't. And so I took my job pretty early on as someone who was interpreting what he was looking at, but I had to interpret it relatively quickly because I was looking at it for the first time too. One thing you want to remember is there is nothing more exciting than seeing a piece of seafloor that no one has ever seen before for the first time. We're seeing the same thing on Mars. Every time I see a rover picture from Mars, no set of human eyes has ever seen that terrain before. Same thing is true in ocean exploration. Where we go, no one has gone before. So I'm going to play this first clip, and this is a woman named Millicent Cummings, who is brand new to the game.
Have you ever wondered what may lie beneath the ocean's surface? Miles below where sunlight ends, it might seem a dark void, vast and empty, lightless. But within the darkness, things yet discovered abound. You just have to look.
Does she have a great voice or what? That woman could talk to me about anything, all day. And she was found by a young colleague. We were putting a 5-minute promo together for the Oceanus Explorer, and he's a videographer, so he was handling the camera work. And I'm not going to show the whole clip, but it's on the Oceanus Explorer website, the NOAA website, but she narrates the video. And where he found her, I have no idea, but the voice is part of it. So you'll hear some of our narrations tonight, and the video itself, if there was no voiceover, would be impressive. But because people like Amanda and myself and Andrea Quattrini in the back there, we have to interpret as we go. So you're getting the translation. And that's a lot of fun for us because we don't always get it right. But we have earphones on and we have experts whispering to us. That's a particular kind of shrimp. That's a particular kind of crab. That's the crab we're looking for. Anybody can sound good when they've got headphones on on the ship and helping you interpret your results. But keep that in mind as we go. I thought I would take this title to heart and try to answer the question up front. Why is ocean exploration important to the United States? In my opinion, it's because ocean exploration embodies the qualities that have made and continue to make this country the greatest country on earth. And make no mistake about it, there aren't a lot of countries that can do ocean exploration. We're not the only country doing it, but I think these qualities, a burning desire to advance the frontier, we've always been a country that was about advancing the frontier. Most of us came in on the east side, and we worked our way west. Most of us came to Alaska from the south side, and we're still working our way across Alaska. And now we've got a big piece of terrain called submerged America. It's an enormous terrain, and we're working our way through that frontier as well. We've got an equally intense curiosity to understand the unknown. That's a human trait. We all want to understand the unknown. But I think America allows us to execute that burning desire. A lot of countries don't want you to execute that desire. Who's traveled a lot? Other countries. It's not so easy sometimes to express yourself in those countries. We live in a wonderful place where you can express yourself, where you can ask tough questions, where you can address the unknown, and people go, bravo. I think it's a great thing. There's a certainty in this country that if we push the frontier and try to understand the unknown, we work towards stewardship of the environment. And Amanda's going to touch on this. Amanda's the biologist. She'll follow on from me. I'll touch on it briefly, but I'm going to say over and over again that ocean exploration is about partnerships. It's expensive. The technology is expensive. The individuals are educated. It's a tough business to get into and stay into. If we don't have partners in this quest for the frontier, in this quest to understand the unknown, we can't get it done. And stewardship's a good way to realize those partners and to make those partnerships a reality. This country is well known for its commitment to making opportunities available for the next generation. That is known all over the world. I work for one of the biggest universities in the country, University of Texas at Austin. We've got 38,000 undergraduates. They come from every state and country in the world because countries know that we put out good educational products, and ocean exploration is no exception. We do a really good job of identifying some of the best young minds, giving those young minds opportunity to tackle important problems and develop advanced technology, and then use that technology in the field. And then finally, we take that technology to do all of those preceding things. But I want to leave you with this. Some of you are donors. This is expensive. The commitment is very, very real. From a human point of view, from a technical point of view, it's expensive. It requires passion on the part of the people doing it, but it requires dollars too. And we are living in a world in the early 21st century where the United States has decided to coast a little bit on science and technology. Our government has decided that except for the military, we don't need to be on the front line in science and technology anymore. We're good to go. Nothing could be further from the truth. And ocean exploration is a place where if we don't expend the human capital, get the best people in play to reach out to the next generation, to reach out to all the young people in this aquarium through the videos we produce, we won't stay on top of the heap. And and we're talking about planetary survival here in the next 100 years. Ocean exploration is, to me, about humans living in harmony with the environment, and if we don't figure out a way to do that in this next century, we're in a lot of trouble as a species. Most species that have ever inhabited the planet are gone. And people say, gee, global warming, is it going to be a problem? I say, planet's going to be fine. Planet's 4.5 billion years old. It's going to be between 10 and 12 when it disappears. Sun will take it out eventually. We're the problem. Planet doesn't care whether we're here or not. So when somebody asks you, is the planet going to be okay? You say, sure, it's us. It's going to be the problem. Okay, 50 years ago, when I was in elementary school and high school, we were tackling outer space, right? You know, I was 10 when Alan Shepard left on Freedom 7 in 1961. Some of you will no doubt remember that as well, since I see a few other gray-haired people out there. And I had just graduated from high school when Apollo 11 landed on the moon. This was big stuff. Now, let's not kid ourselves that we landed on the moon because of the science and technology. We landed on the moon because the Russians were trying to go to the moon too. Right? But it was exciting to be a young person then. And it was in the media too, where no man has gone before. Star Trek, same time, 60s. Star Wars in the 70s. A long time ago in a galaxy far, far away. Who hasn't been actuated by those media journeys to outer space? We had Sea Hunt. Do you remember Sea Hunt? Remember Lloyd Bridges and Sea Hunt? Not the same kind of show. It was more about the cult. It was Lloyd Bridges, right? It was Mr. Lloyd Bridges with an old aqualung, and not the same. Didn't have that same sense of passion and commitment. Fun, though. But there was Jacques Cousteau. And Jacques Cousteau I was in Woods Hole in '76, and Ballard's walking down the hall, and there's this little guy next to him. Cousteau was really small. And John Denver was next to him, and John Denver was even smaller. They had just formed the Calypso Society, and this guy, Ballard's 6'2", and Cousteau's was 5'7", and Denver was 5'4", you know, so they all were coming at me, you know, and it takes a minute to recognize who these people are. But Cousteau towered over all of them because he was such a charismatic figure. And we still need that. Charisma is a part of what we're trying to do here. The oceans are charismatic. We need to sell the charisma, but we have to be charismatic too. Because Ballard, his favorite picture is to show an 8th grader with her mouth like this, looking at his videos. If he ever comes here to give a talk, he will show that woman. And it's the perfect blend of awe, wonder, and he does that. He does that. And we've all got to do it. Charisma's part of it. We had charisma in outer space, now we've got to have charisma in inner space. And that's the message I'm trying to say. And outer space, we can study Mars, we're going to Europa, and there may be life out there, but it won't affect our ability to live here. Understanding the oceans will affect our ability to live here. And that's the great imperative, and that's the message I want to pass. We've got to do this not only because it's exciting, but because it's important. It's necessary for human survival. I don't know, I can't remember my own talk. Submerged America. Talked about advancing the frontier. Well, we moved east to west, right? California, the Spanish kind of snuck around and came in here too, but mostly we marched west. Well, now we've got an enormous submerged America to deal with. This is all the acreage under the oceans that we have purview over, economic, political purview, and we have a big job to do. So to me, advancing the frontier now no longer means go west. It means go to sea. And we are in the process of doing that. We recognize it now. Amanda works for the U.S. Geological Survey. One of their goals, this map on the right is from the U.S. Geological Survey. This is one of their primary goals, is to understand submerged America, its economic potential, its political ramifications. But we've got islands out in the Western Pacific we've got to look at, shipwrecks to explore, and this is all part of our political mandate. Fortunately, we've got two national vessels now, and you've seen them both. The Ocean Exploration Trust vessel is Ballard's vessel. It's an old East German fishing boat. And both these vessels, the Oceanus Explorer is on top. She's the NOAA vessel for ocean exploration. Both of them are headed to the Pacific. And they'll be there for a while. Nautilus has been in the Mediterranean and the Caribbean. The Oceanus Explorer has been on the East Coast in the Gulf of Mexico. I'll be talking about some of those dives tonight. But both boats are headed for this enormous piece of submerged America out in the Pacific. It's going to be really exciting. Both of them will be out there for years. And you'll be able to go explore with us. This is an ocean. Balboa called it the Pacific when he saw it on the Isthmus of Panama in whatever it was, 1513, but it's not a Pacific. It's not a quiet ocean. It's a big ocean. So this will be a big challenge. But both vessels are headed there, and stay tuned with us while we do that. I'm going to hit understanding the unknown with a number of examples. Most of these, on purpose, are taken, these are video clips taken from dives that I narrated, mostly in the Gulf of Mexico and on the east coast of the United States. I did that on purpose because I know a little bit more about the dives. So let's play this first one. This is an aerial view of a brine pool. Does everybody know what a brine pool is? A brine pool is a supersaturated saline solution that sits under the seawater on the seafloor. I hope it plays. There's the brine, and there's the shore, but we're in 1,500 meters of water. These are outcrops, they're called carbonate outcrops or carbonate hard grounds. The brine forms when the enormous layers of salt under the Gulf of Mexico get up to the seafloor and begin to dissolve. And that supersaturated solution just sits down there, and if you poke your finger in it, you would send little ripples and waves out, and we've done that. It's got little tributaries that come in, but you're in 1,500 meters of water. A lot of the biology lives in quite nice harmony with this, and we've got chemosynthetic organisms that are part of this because along with the salt, when it comes up to the seafloor, you've got hydrocarbons coming up in the Gulf of Mexico along with the salt. So here we have some tube worms, which a lot of you have seen. These are worms that are often associated in chemosynthetic communities, and that's 10 centimeters, by the way, those lasers. They're living quite harmoniously with hydrocarbons that are leaking out along with this dissolving salt. We see this all the time in the Gulf of Mexico. Biology living in harmony with noxious environments, supersaturated salt, hydrocarbons. It's been one of the big, big surprises in the Gulf of Mexico.
But how is that changing
Well, let's play it again. Let's play that video again. This is about 300 kilometers, about 200 miles from Macondo. What we've learned, and we're still learning, is that it's not that the biology can't live in concert. There's a dead mussel right there, but there's a live anemone. They can live in concert with hydrocarbons, but Macondo was too much of a good thing in one place. These corals can be hundreds, if not thousands of years old. They sit in one place, like trees. They can't get away. So a little bit is a good thing, and I'll show you another example of that shortly. Too much is bad. Now, I don't know, Amanda, what the radius of effect of Macondo's been, but it's been kilometers away from the well site, but not this far away. But why is this important? We need to know what the natural seepage of hydrocarbons are in the Gulf of Mexico. If there's another Macondo going to happen, we need to find out how much is too much. One estimate has 100 million barrels of oil leaking out of the Gulf of Mexico naturally a year. Naturally. But it's dispersed. So the biology's fine with it. But you put thousands of barrels out in one spot at high rates, that's a problem. It's a big issue. Let's go to the next one. Oop, 2, there we go. Here's another example. Again, Gulf of Mexico. This is in about 1,200 meters of water. Live mussels. That's methane ice, methane hydrate. So it's a loose crystalline agglomeration of water and methane gas. These hydrates come to the surface along with these rising evaporites or salt, and they freeze on contact with seawater, and then you've got the biology living quite comfortably with this disseminated hydrocarbon release. The ice is right there, and in the next clip you see something we call ice worms. They live actually in contact with the methane. They're living on bacteria, they think, right in contact with the methane ice. These were found in the late 90s by a group from Penn State. No one knew that organisms like that could exist. And we're seeing a lot of these types of ecosystems now and hydrocarbon releases all over the Gulf of Mexico. Let's do the next one. Oop, sorry. Here, I'm going to show you some active leaking of gas and oil now. This is in about 1,200 meters of water. Same dive as that methane ice. That's oil, that's gas, natural gas, and there's a nice mollusk living right next door. No problem. We're trying to quantify these rates of release now of hydrocarbons with some technology that we're beginning to develop to deploy from the ROV. So we can actually begin to volumetrically quantify how much oil and how much gas is releasing. But that day on that dive, we were 1,200 meters up with the ship, and we had droplets of oil coming up all around the ship, forming a slick around the boat. And you would say it's pollution. Well, perhaps it is, but it's naturally occurring. And the biology at the seafloor doesn't have a problem with it. So pollution is a relative term. We pollute because we disturb the natural environment. These organisms are quite comfortable with dispersing themselves around natural releases of hydrocarbons, and these can be relatively rapid. That oil and gas stream was a relatively rapid release. But a lot of these organisms are all right with it. We've got to be careful. Mexico is opening up the western Gulf of Mexico for oil and gas exploration right now, and they have very little experience drilling in deep water. So we have interesting times ahead in the Gulf of Mexico in terms of more potential releases of serious flows of hydrocarbons. But that's the problem for both the organisms in the water and organisms on the seafloor. It's the rate of release, not that those hydrocarbons don't exist. Okay? Let's go to the next one. I've been showing you hydrocarbons, but there are 3 major canyons dispersing sediment from north to south in the Gulf of Mexico. This is one of them, called Bryant Canyon. And this is a map that the ship made of the seafloor. Well, that map is only good to a mapping size of about 5 meters by 5 meters. And it showed us, we did this dive because we thought we would be seeing corals. We were down there to look for corals on the flank of the canyon. That's why we went. Looked like a relatively featureless slope, some divides in it. Let's play the video. What we saw were a whole series of gullies and rills, 2 to 3 meters deep, 1 to 5 meters across. No corals, but plenty of topography. One of the big mechanisms for sediment dispersal from upslope to downslope in this part of the Gulf of Mexico. Couldn't see it on the surface maps that we made from the boat. No life. Why? Because corals, which are hundreds to thousands of years old on the seafloor, they don't want to live in an area that's this active. That's the Deep Discoverer. She's about 3.2 meters long and 2.5 meters high, so you can see what the scale of these features are. Wasn't any sediment moving that day. Water's very clear, but this is a geologic feature that is indicative of downslope and catastrophic downslope movement of sediment. That's how the Gulf moves. Only periodically. If that Deep Discoverer had been there when one of those downslope sediment flows had happened, we would have had a serious problem on our hands.
So are you talking about something moving pretty much like a big sand dune?
If you look down on a river channel from a plane, big meander bars, and right, that's what this is. This is an undersea river plane.
Are they coming off rivers on land, like in this?
The canyons are dispersing water and sediment from the northern part of the Gulf of Mexico. The primary river is the Mississippi. This is mostly submarine movement of sediment. We call the turbidity currents, density flows that are actuated by seismic activity, by the upward movement of evaporates. These salts, these brine pools I showed you earlier, the Gulf is a big mix master. The sediment thickness under this area is about 8,000 meters. And some of it's salt. So that salt, think of taffy in a heated pot, caramel in a heated pot. It comes up in big, long fingers. When it does, the overlying sediment gets unstable and begins to move downslope. So what we were looking at there was something we absolutely didn't expect. But the implication for the biology was fundamental. We thought we would see a nice habitat for deep water corals. We didn't see any corals because those corals require stability in the environment, and there was no stability on the order of the lifetime of those corals, which is hundreds of years. The day we were down there, there wasn't any sediment moving at all. But because of the landforms we were seeing, we could tell that this was a very, very active environment. So everywhere you go, there's excitement, there's a surprise. And this is why we explore. This is the message we just have to keep coming back to. That red rectangle is kilometers on a side. We didn't get anywhere near that much done on the ROV, right? We went through most of our waypoints, most of our dives go 500 to 1,000 meters across the seafloor. So in 6 or 8 hours, that might be what we do. That's a very, very small line segment within this red rectangle. The complexity we see is fundamental on almost any scale we look at, biological, geological, but the commitment we have to make to do the mapping we want to do is enormous. Right? Let's do the next one. Knowledge leading to stewardship. This is the only dive that I was involved in off the East Coast that I'm going to show you. Amanda may show you some more submarine canyon dives. This is an important part of what NOAA is trying to do with partners to understand ecosystems in submerged America. How does the biology interact with the geology? Are there important species down there, commercially important? Can we play that one? Let's do it. This is in water depths of about 1,000 meters. That's a commercially important species of squid. That's a chase-yon crab. That's a red crab. You've eaten them. The reason we were in these canyons was to understand the relationships with this biology, which we didn't know much about. Didn't know much about the behavior of red crabs, how they interact with squid. And if you look up in the upper left, you're going to see something pretty fundamental in a minute. The squid are moving around enormous density. That crab's still after that squid. But look up in the upper left. There's a goosefish. Just took that squid right out. We had seen that goosefish earlier, but we didn't know that he was going to do that. And then here are krill or euphausids on the camera sled above the ROV. We saw an incredible diversity of life in these canyons. There are many, many canyons off the east coast of the United States. They're birthplaces. Let's play that video again. These are birthplaces for life. They're where a lot of commercially important species interact, but we simply don't know enough about them. And these dives are partnerships with not just NOAA, with the U.S. Geological Survey, with state agencies in fisheries, with, and I'll show you a list here in a second, but all of these are money makers. The squid are money makers, the crabs are money makers. How many should we take? How hard should we fish them? We don't know enough about them to be stewards of them. And that's what these dives were about. But again, we're covering a very, very small piece of terrain in these canyons. These canyons are enormous submarine valleys extending from the edge of the continental shelf in a couple of 100 meters of water down to continental slope depths of 3,000 meters. They're enormously complex. So for us to do a really good job of mapping these would require years, and we've had dozens of dives, nowhere near enough. Something else to keep in mind. Next one. Oh, that's me, sorry. Deep water corals have been an enormously important part of what we're doing in ocean exploration, and there's an important reason. They're canaries in the mines. They're sessile organisms. They stay in one place. They like tranquility. They like an environment that doesn't change very much. They're hundreds of years old, and they don't move. Now, they reproduce by sending out larval phases that move, but once the organism is attached, it's attached. Let's play this one. We're down in about, oh, wait a minute, next one. We skipped one. I don't want to show that one first. Let's go back. This is on the Florida Escarpment on the east coast of the United States in about 1,900 meters of water. These are big, big blocks of carbonate with bedding planes, the divisions between the beds, the flat surfaces you see, and these are deep water corals. In these water depths below fishing pressure, it's a pretty tranquil environment. It's a very strong current environment occasionally, but these corals don't mind current. And we see forests of these at times. And I'm not going to talk about the names. I'm going to let Amanda do that. Amanda and Andrea are the experts on this, not me. But one of the big drivers for us in a place like the Gulf of Mexico, which is known for hydrocarbon exploration, which has been, some people call it the Dead Sea. The view is that because there's been so much oil and gas exploration out there, there is no life. So we don't have to worry about it. Nothing could be further from the truth. There are enormously vibrant ecosystems out there, many of them living in harmony with hydrocarbons. We are the problem out there when we disturb these ecosystems. They're okay. I'll show you an example now. Let's go to this next one. Now we're in 500 meters of water, just above that dive we were in before. See that? That's us. These are Lophelia. This is another deep water coral in about 500 meters, and that's a trawl mark. That's where fishermen have come through, and there it is again, with the deep discoverer in the foreground. And it's taken that colony and just bisected it. And once these organisms are disturbed, these organisms are hundreds of years old. They don't regenerate easily. Went right through that bank from right to left and left a big scar. 500 meters. Now, you could say, well, the fishermen don't know that. That's true, but we know that. And we are working now with fishing organizations to try to help them understand what impact they have, try to identify these resources that can be easily disturbed by fishing activities, and get them to perhaps impact less or impact not at all some of these organisms that are very sensitive and once disturbed or ripped apart don't regenerate for hundreds of years. Yeah? Finfish. I mean, these are otter boards, right? These are, so most big trawl nets have got boards that come out to the side to keep the net open. So the net is not impacting the corals, but because the boards are big, heavy wood, metal, think of big tongue depressors on either side of these things. They're keeping the net open. The net goes down to a little pocket at the end, and that's where the fish are. This is a very, you know, this part of the Florida Shelf is a very, very, it's the precursor to the Gulf Stream. It's called the Florida Current. It's the loop current of the Gulf of Mexico, which becomes the Florida Current, which becomes the Gulf Stream. So this is a productive part of the Gulf from a fish point of view. You can't blame the fishermen for going after fish. What they don't know is when they're doing that, they're impacting organisms that they impact that are hundreds of years old. And if we work with them, we do a better job of helping them help themselves. We don't want them not to fish, but we've got to figure out a way to help them understand what they're doing beyond the fishing. They don't want to do this, but they do it, okay? Okay, next one. Okay, you can't talk about stewardship without talking about shipwrecks. In April of 2012 was my first expedition on the Oceanus Explorer, and the Bureau of Ocean Energy Management, which is the federal agency which is responsible for taking oil company data and then helping the oil companies get permitting for oil and gas exploration. Oil company data had shown some evidence for what looked like a shipwreck on the seafloor in about 1,500 meters of water. I can't show you the location. We had the White House with us online that night on the Oceanus Explorer because that expedition had been showcased by the White House. But it was a bad day. The weather wasn't very good. And we almost canceled the dive. And I said, we can't. Come on. It's a shipwreck. You have to go down there and at least take a look. Well, we did. And we ended up with a copper-clad, early 19th century ship of what turned out to be the first of 3 ships. And this is a photo mosaic that Oceanus Explorer found the first wreck, but this is a photo mosaic of the wreck. That piece of the wreck there is that piece, the stern. That piece up there is the bow. That's where the anchor is. This was a fleet of 3 that went down. And that was the most awe-inspiring night you've ever seen because we saw plates, we saw muskets, we saw stoves, we saw cannon, and the Oceanus was not sampling. Nautilus has sampled ever since 2009. The Oceanus is yet to sample. We are a video boat right now. But we saw bottles of every type and description. Some were full, and some of what they were filled with looked dry. It looked like even though they were down in 1,500 meters of water, that their foodstuffs were still intact. What was in the bottles. I was loving it. And so instead of staying down for 2 hours, we stayed down for 6. I'll show you now a couple of examples of what we can do with shipwrecks. Ballard will tell you, if Ballard were in this room, he would tell you that it's all about education, it's all about understanding everything the oceans have to offer, but let me tell you something about Ballard. He loves shipwrecks, right? He once said, he found the Titanic, everybody knows that, but at one point, 3 or 4 years ago, he told me, he said, look, the Titanic sank, get over it. But that's not the way he really feels. I mean, everybody loves shipwrecks, right? Let's show this first video. And this one's got a narration on it. Oh, next one, it's the one before. It's all right, we're going to see them both. Can we start that one again? We're looking at this first shipwreck that I just showed you a photo mosaic of, and we're looking at navigational instruments on the seafloor. Here and here.
That's correct. We believe what we've got is the instrument buried in sediment. And, this is an earlier version of the section. But looks to be glass with a rim. I think it's an instrument of some sort. Okay.
That's me on the ship talking to somebody ashore.
There's a hand inside of it as well, as if this is a chronometer. Yes.
Yeah, marks on the edges.
That's a chronometer. Wow, great.
That night, we had a group with us on Telepresence from all the news agencies in Texas because these wrecks were close to being in quote, Texas territorial waters. When we found this sextant and the chronometer sitting there, we made the front page of the Houston Chronicle. So everybody loves shipwrecks. We are going to go back into, this next one I'll show you now. Let's go ahead and run this video. Or the next one. Yeah. Nautilus went back, we found the shipwrecks in 2012. Nautilus went back and began to sample these bottles. That one full of dry cereal. Bottle going down to 1,500 meters and didn't break. Full of cereal. There's a cup. And there, haven't yet, but they've got the dates pretty much down. Early post-1812, and it was probably a privateer with a couple of prizes. It was a group, it was a fleet of 3, right. But they were all copper clad, which is the reason that they were so well preserved. One had plates, muskets, bottles. The other one had hides, rolls of leather hides. I haven't got a video of it, but those rolls of leather hides are now being colonized by tube worms because the hides are organic, they're breaking down, and these tube worms, which reproduce through larval distribution, have found these hides and are quite happily living in association with these hides. So we know that these tube worms are colonizing this piece of the seafloor in less than a couple hundred years, quite happily. So, and more excavation, we want to get a cannon from here, we want to get one of the stoves. We still haven't got anything that actually pins down the name of the vessel, name of the vessels, or the absolute year, that they've got, they know what they want to go after to do it. Okay, let's go to the next one. I talked about partnerships. Another lesson I want to leave you with tonight is that if ocean exploration is going to survive, it isn't about NOAA making a commitment. It's about a lot of OER stands for the Office of Exploration and Research at NOAA. They work with other line offices at NOAA that have much bigger budgets. The National Marine Fisheries, the Center for Coastal Monitoring and Assessment. The ocean exploration budget in NOAA is on the order of $25 million. Well, NOAA is a multi-billion dollar a year agency. So this is small stuff. But the canyon dives that you saw were in partnership with the U.S. Geological Survey. So that was an important partner, and they paid for some of these dives, and with various state agencies, fisheries agencies in Maryland and Virginia, for example. So this is the kind of partnership that we've got to generate because this costs money to do this, the technology costs. And then the individual scientists, we're giving our time through telepresence. We're on board because we love seeing seafloor nobody's seen, but we cost too. But most of us work for universities, and universities understand that we should do this. But these people cost. Ocean Exploration Trust, running the Nautilus every year, runs about $7.5 million, and that's for a 6-month program. Ballard gets 2/3 of his money from private donors. Only $2.7 million of that comes from NOAA. And so to all of you who are interested in supporting things like the aquarium, I say to you, this is another very, very worthy activity to support. I've started a foundation with the head of ROV development for NOAA, a guy named Dave Lavalvo, called the Global Foundation for Ocean Exploration. Go look at the website. And we are beginning to raise dollars for private dollars to support this activity. So I'll be more than willing to talk to you about it. I kicked it off with a 6-figure gift of my own, because you got to put your money where your mouth is, right? And I have a big mouth. So you've got to do that, but I'm really interested in figuring out ways to augment government-based resources with private money. It's really important, and it's going to be the salvation for us. Next one. There we go. Let's run with this. This is a short clip. I just want to touch on the training aspect of this. I'm going to show you a short clip of the pilots in the front row of the Oceanus Explorer. Some of the smartest young guys on the planet. Navigation, running the Deep Discoverer, and running the Sirius camera slip. These guys are out as trainees from some of the best engineering programs in the country. Let's just keep playing that one over. Todd Todd Gregory in the foreground, he's the senior guy, although he doesn't look very senior. He's married with a couple of kids. But he's training the others along with some of the senior people on board. We have some of the best young engineers in the country out there. They're getting frontline experience on not only maintaining, designing the ROVs, but running them. And believe me, getting a joystick in front of you and running that deep discoverer in complicated terrain, this is a multi-million-dollar piece of equipment, isn't easy to do. And all of them get a chance to do it. Yeah.
When you were talking about the shipwreck earlier, I remember when we were watching live footage during excavation at Shipwreck, and I was up watching it one day when the ROV was trying to delicately pick up a pair of trousers off the ocean floor, and he just kept picking them up and dropping them. And I felt like I was going to have a heart attack because I was worried about the people running the ROV and how stressful that must be. And then later somebody told me that each arm was operated by a different person.
It can be, not always. We were on the Nile Delta with the Nautilus, and we were on one of these big meanders on the Delta. The Delta's enormous, right? But we were in about 1,000 meters of water. And we found an amphora. They're amphora. These are the Roman Coke can, right? So you see Coke cans everywhere else on the planet, but in the Mediterranean they're amphora. Well, this one was a very unusual one. And we were online with the Israeli Antiquity Authority, and they wanted that amphora. We generally were not taking them. We were leaving them in place. But then it took, and National Geographic was on with us that night, and we had to be so careful picking up this clay pot, which had ears. It was ornate, had little handles. And everything on the seafloor looks big, right? Part of it is that the cameras are so good at zooming in that you tend to forget that things are actually quite small. When we got it up to the surface finally, it was about that big. And I went, that's disturbingly small. But it just underscored the skill of the pilots, because you had to zoom in, come back out, make sure. These mechanical arms, these are not shaking hands with your grandmother, You can crush something very easily if you don't know what you're doing. So these guys are all really good at what they do. Plus, they get online with us and they're trying to sell what they do to everybody else. So when we talk about the next generation and how important it is having a technically trained group of people, we've got some women too. This is a group of guys, but we've got women doing this as well, and running the mapping systems and doing all the elements on the boat. This is an important part of what OE is as well, is training. Okay? Let's not forget about that. Let's do one more. This also has a narration. Next one. Oop. Yeah, let's do this one. I just want to show a launch sequence. All the voices you hear are these young guys. We lost the voices. Well, there were voices on this narration. We got the music, we lost the voices. Nonetheless, the point to showing a launch sequence was this is a dance between a deck crew, between those guys in the room, in the control room, and guys handling the ROV, the two-body system on deck. And almost all of these guys are young guys that are being trained to do this. And it is a ballet. It's a deck ballet. It's an amazing thing to watch. They're really, really careful. The technology is really expensive. Let's go to the next slide. We don't have to worry about that. I just want to take the Deep Discoverer ROV as an example. You've got underwater video cameras. You've got newest LED lighting technology. You've got sensor payloads, and you can put any kind of sensor on. Everything from dissolved oxygen to looking for hydrocarbons. These hydraulic manipulators, these arms, 2 of them. Oceanus Explorer is going to start sampling this coming year. Nautilus has been doing it since 2009, but Oceanus is going to start doing it now. Sector scanning, you've got to find out when you're on the seafloor, you've got to look ahead and find out where the ROV is going. We're at the surface, we're 1,500 meters away. Sector scanning, so think of these guys with a joystick in front of them. They're manipulating the ROV, but they're looking ahead to see where the terrain is in front of them. Anybody who gets a chance to see these vessels, get into the control room. It's really spectacular. You talk about multitasking, there's simply nothing like it. And we're looking at an investment of millions of dollars. Millions. And it continues. The people are expensive, the sensors are expensive, the hydraulic manipulators, $200,000 a piece. It all requires continuing commitment and money, and I leave that to you. We simply don't have the resources we need to do it. And then it all costs money to deploy and recover. So let's go to the next one. Oh, that's me, sorry. Okay, this is my last one, and I'm doing well because I have 5 minutes to go. Don't worry, Amanda. You know. In the end, exploring the oceans is exciting and fun. This is a little bit of a setup. This is a Sidescan sonar record that was taken by Shell Oil in about 1,900 meters of water in the Gulf of Mexico. The Bureau of Ocean Energy Management, I remember I told you, was the organization that works with the oil companies to permit oil and gas drilling in the Gulf of Mexico. This is called a nadir line. So what a Sidescan sonar does, it sends out a bunch of beams that kind of scan for topography on the seafloor. Things that bumps show up as hard echoes, right? Well, they saw this one, and the nadir line is something where you don't get a return because it's right under the instrument. They said, well, that's the bow and the stern, or the stern and the bow of a ship. They're about 200 feet apart. So we set this dive up as a shipwreck dive. And we had a bunch of archaeologists online with us on Telepresence, salivating. These archaeologists, I do too. I mean, shipwrecks are exciting. So now I'm going to show you the video. Look like a shipwreck to you?
If you look at the overhead image of this, it does exactly look like that. Yeah, well, it's not always clear, Jack, that this would have a root. I mean, this could have formed rather deeply in the subsurface and be coming up as an exotic.
Looks like a pedal, doesn't it? Series of pedals?
Coming up from great depth in the north-central Gulf of Mexico. The salt is an igneous rock formed probably when the original oceanic crust of the Gulf was formed 140 million years ago, and who knows how far up it's come from depth. And it's rootless. It's just a piece of material that's ended up at the seafloor. This is looking increasingly like a natural object, though, not man-made.
And there were two of them.
Given the curved nature of the surfaces and their smoothness, I would have initially said that it was man-made. I'm increasingly looking at it now, and particularly in this view we're seeing in D2 now. It looks almost like an open flower, and it looks like it might have been some kind of subsurface expulsion of hydrocarbons that froze in place and have come up from the subsurface.
It's asphalt.
In place. Remember that not all, we tend to think of seeps as either gas or fluid hydrocarbons, but a lot of the hydrocarbons we know about can be quite, they can have APIs that suggest they're much more like molasses or taffy. And this is looking more like that. I'm going to call them petals from now on. This looks like a tar rose to me, or a tar flower.
I see this has been described as a tar Easter lily.
Tar flower, tar Easter lily. 'Tis the season for an Easter lily.
It was April.
For all of you young people looking at us, lest you...
That's a piece of the pipe that brought it to the surface.
There's a reason to study the ocean. This is a classic example of the fact that we don't know a lot more than we know. And it's really, really exciting to me. I've been in the business 40 years, but this is another surprise to us. To see something like this is a pretty spectacular example of why we explore. And we've got a lot more exploring to do.
These were pipes of asphalt that came up hot, came to the surface, and just exploded into flowers. There's only one other place in the Gulf of Mexico they've ever been seen. And they were now rootless. There was nothing in the seismic data that suggested where they came from. They might have actually come up to the surface somewhere else in the Gulf of Mexico and then just kind of floated down the way sediments move in the Gulf along with. And bottom line is we thought it was a shipwreck, not a shipwreck. There wasn't just one of these, there were two. And they were just a couple hundred feet apart. So I'm going to end up here, and I'm just going to say, look, I'd love to answer more questions if there's time later. What's embodied in ocean exploration? It's the vision to tackle inner space. It's partnerships, it's expensive. It's educating the next generation of marine engineers, not just those that have the opportunity to be on the boat, but those who see the opportunity through looking at us on the web and through videos and then get excited. It's all the people, the young people in this aquarium who get excited about seeing these things. And finally, it's the commitment to technology innovation and development, which I think has set this country apart forever. And I hope that America will reinvigorate itself as the world leader in helping humanity live in harmony with the oceans, because the consequences are going to be a bit dire if we don't. And ocean exploration is a wonderful example of how we can do that. Well, I want to thank you very much. And I've used up my time. I appreciate it.
Well, thank you all for the opportunity to come speak here today. As Jerry mentioned, I'm an ecologist. I work for the U.S. Geological Survey, and if I'm allowed to, I'm going to move this to the side so I don't have to speak through the microphone. Just before I start, I wanted to share with you a story, a personal story. As I was preparing for this talk, I have a daughter. She's 9 years old, and she inspires me every day. We get along pretty well most of the time. But one thing about her is, I'll get a gift, maybe a piece of jewelry, and she'll say to me, "Hey, Mom, can I borrow that sometime?" And I'll usually say no, or if I'm being generous, I'll say something like maybe, possibly. And you may be wondering why I'm talking to you about this story is, well, recently she got this book from a friend of ours, and I was recently invited by Jerry to give this talk to you all, and I thought, oh, this is pretty prescient for this friend of ours to give Clara, my daughter, this book. And so I said, "Hey, Clara, can I borrow this book from you?" And she said, "Sure, Mom, what do you need it for?" And so I said, well, I'm giving this talk, and I think, this might give me a head start on what I need to talk about as far as giving some understanding of where we came from and where we're going. And she said, okay, no problem. So I guess the short story is that I need to learn something from my daughter about how to share. But ultimately, as I mentioned, in order to see where we're going with regards to ocean exploration and how it's advancing science, we need to see where we've come from. And so the first part of my talk, I'm going to give an overview of the history of ocean exploration and marine science. I noticed as I was walking through the aquarium today that there is a very nice exhibit of ocean exploration here, and it gives a nice timeline, a very thorough timeline of ocean exploration through history. So this is a bit of review for some of you, but I believe it's important to emphasize, again, our historical perspective to see where we're going. Well, the Phoenicians are known to be the first navigators, human navigators. Exploration's been part of the human history since recorded history. And they were instrumental in navigating various parts of the Mediterranean Sea. The Pytheas, I would be remiss if I didn't mention a good Greek in this talk, given my name is Demopoulos. Pytheas was well known for using or calculating latitude, and he provided some insights into his explorations of the northwest European area. Ptolemy, around 150 AD, produced the first map of the world, and at the time, the map contained what we knew of Africa, Asia, and Europe. And what's interesting about this map is that on the fringe of the map is essentially the seas that we knew of them at that point. And that map provided inspiration to explorers, generations of explorers since his time, because what they wanted to know was what lies beyond the fringe, what's going on beyond that fringe of the sea that he mapped. And Vikings, well, they're well-known explorers, mostly by mandate. Some of them were sent away from the mainland and had to explore to find a new place to live, essentially. And they discovered Newfoundland, and Greenland, and Iceland, followed by the Chinese. Chinese invented the stern post rudder. This is a fundamental part of steering ships at the time and was adopted by Europeans. And in addition, they were known to use compasses to use for navigation for quite some time. Our earliest explorers around late 1400s, early 1500s include Christopher Columbus, Magellan, and Vasco da Gama, mostly driven by finding alternative routes to the Spice Islands to persist the trade. Ferdinand Magellan and also Del Cama were known to, they've circumnavigated the globe, first to do that, and that represents the most major exploration event that occurred at that time. Now, much later, due to the interest of the British to help persist their dominance at sea, as well as understand more about the globe around us, James Cook's expedition on the Endeavour represented 3 phases. Each particular expedition is delineated in color, and we see that the first one is in red, the second expedition is in green, and then the blue was this final expedition, which ended abruptly on the Big Island of Hawaii, where he was killed in Kealakekua. However, his expeditions provided us with major insights into the distribution and location of different islands. There are major maps that were created through these expeditions, among other major insights regarding oceanography and meteorology. He accurately calculated longitude, so the maps that James Cook Group was able to produce provided us with maps that were used for a long time. The expeditions provided us with major insights all around, and including some observations that occurred regarding coral reef environments that helped inspire Charles Darwin and his expedition on the Beagle, which ultimately was initially supposed to only last 2 years. It lasted 4 years and 9 months. I can't imagine leaving home and saying, hey, honey, I'm leaving for 2 years and not come back for 4 years, 9 months, let alone actually trying to organize an expedition for that long. In this day and age, it's hard enough to get everyone coordinated to do work for 2 or 3 weeks, let alone multiple years at a time. But it's quite amazing what they were able to accomplish in that time period, and the number of collections that they amassed during the Beagle expedition yielded some important insights into the biology and ecology of the environments investigated. And Darwin is obviously well known for the publications that resulted from those collections, including his work on evolution. Well, in the last few years, as I've been doing more work in collaboration with NOAA and ocean exploration, I will step back and say that exploration is a fundamental part of what I do in my research program. It's a major first step in understanding and developing hypotheses, is to observe. And I'll follow on that in a bit, but when I have been inspired by all of the work that's been done previous to me, and this particular expedition was unknown to me until recently, and this is the USS Exploring Expedition, the USXX, that occurred in the mid-1800s, and Captain Wilkes led the charge of a squadron of 6 vessels, essentially, and you can see the pathway that was taken, starting in New York and around and throughout the world. And essentially, his expedition amassed about 60,000 specimens that ultimately led to the development of the Smithsonian Museum. They needed a place to put all of the collections, ultimately, and in order for that museum to be developed, one of the justifications was to actually house this expedition collection. Now, Captain Wilkes, as many captains before him and after him, he had quite a reputation. There was he wasn't exactly a favorite among his crew and was ultimately court-martialed. So that may be why the story isn't necessarily on the forefront of our understanding of our own role in exploration, but I want to emphasize that this is a part of our history and represents a major part of exploration in terms of US's role in that. When I think about ocean exploration and think about our history and human history and exploration, I think back to what I've learned about the Challenger expedition. This was the first systematic, circumnavigated exploration activity that occurred in our history. And essentially, the work, the collections, the information, the data that were collected during this time period fueled numerous publications, provided us with voucher specimens of animals that we still use today to help identify type specimens and give us an understanding of the biodiversity of the environment around us. This represents, the Challenger expedition represents a major advance in our understanding of the ocean environment. Some of the tools that had been used during the Challenger expedition and subsequent expeditions include utilizing materials and gear that collect samples from the seafloor. And I indicate here that it's exploring blind because these tools, this gear, is essentially deployed from the ship without our vision. We cannot see what we're collecting. We only have an idea of where we are on the seafloor based on the survey work that's been conducted there prior to our collections. So while these are important in terms of giving us an understanding of the diversity and biology and ecology of the seafloor environment, ultimately we are shooting in the dark in terms of where we're sampling and collecting that material. And so because of this lack of being able to see where we are, we've been, throughout our history, have developed tools and instruments and technology to help with providing us a way to sample the seafloor and visualize the seafloor firsthand. Again, these gears, this particular technology included a tethered bathysphere developed in the early 1900s, and it provided us a window into the ocean that we hadn't had before. And humans could see firsthand what resided on the seafloor and set depth records utilizing this gear. But it was tethered. That's really not exactly very useful. You're still stuck attached to a ship. And ultimately that led to the development of the untethered bathysphere, which provided the foundation and framework for developing submersibles beyond that. One of the most famous bathyspheres, the Trieste, was deployed in Challenger Deep in the Mariana Trench in 1960. Lieutenant Don Walsh and Jacques Picard descended to the seafloor. They had a few leaks along the way, which would have given anyone pause, I think, but ultimately they descended to the seafloor and were the first humans to see the deepest part of the ocean ever. That particular adventure wasn't repeated until James Cameron's descent in 2012. James Cameron's observations of the seafloor, his images, and observations of sea life provided us with some understanding of the organisms that reside in the deepest part of the ocean. It's really a window into the deep that no one had ever seen before. The development of other submersibles, including the Alvin, and other submersibles from France and other nations, have also provided us other instruments that enable us to vision the seafloor. But I would be remiss if I didn't mention that throughout history, the explorers that I've mentioned thus far have been led by expeditions who are by men. And in this case, I want to point out that women have always been part of ocean exploration in some way, shape, or form. I have given you some examples of women in our history. These are by far only a subset of those who have been involved. One woman in particular that was brought to my attention recently is Jean Barret, and I'm not French, so I apologize for mispronouncing the name, but she lived in the 1700s in France, and she was a naturalist, specialized in plants. And as it happens, she was very interested in exploring the ocean and exploring the world and learning about plants and other places in the planet other than France. And so she had an opportunity, or rather an opportunity presented itself to go to sea. However, at the time, no women were allowed to go on a ship. And so she disguised herself as a man and lived as a man on the ship and managed to explore and become the first woman to circumnavigate the world. However, she's not someone that I learned about in my history classes, as it happens. I will say when she was found out by her crew, that was not well received, to say the least. So she had her own trials and tribulations dealing with that discovery, but ultimately she advanced the science in her own way by taking a chance. She took a chance, disguised herself as a man, and ultimately circumnavigated the globe, and that's pretty fantastic as far as I'm concerned. Women that have followed her have a rich history. Marie Tharp, still in the 1950s, women were still not allowed to participate on offshore expeditions, so she collaborated with Bruce Hazen and produced the first physiographic map of the full ocean seafloor. And a physiographic map includes the topography, the highs and lows of the seafloor based on data available at the time. We had to say goodbye to Eugenie Clark recently. She was a person who was used diving to advance research. She also provided us with really important insights into shark behavior, and up until the time that she was doing work, sharks had primarily been a mystery, and she brought new appreciation to their complexity and a better understanding of their role in the environment. Rachel Carson's well known for being a marine biologist and her conservation activities and advocacy, as well as drawing light to the fact that the healthy oceans are directly relevant to healthy human society, and that we depend on a healthy ocean environment in order for us to thrive. Sylvia Earle is well known within her own right as being an ocean advocate, ocean conservationist, and a pioneer in utilizing deep submergence observation tools. And lastly, but not least, Cindy Vandover represents the first woman to pilot the Alvin submersible. Now, this is a submersible that I've been on dives on before. To actually pilot the submersible, whether male or female, is no mean feat. So the fact that she took the training and ultimately became a pilot is tremendous, especially in the field that we're in. And lastly, she became the first director of Duke Marine Lab. Well, the discoveries that we've made since these advances in technology, Jamie mentioned several. They include the discovery of hydrothermal vent environments along the East Pacific Rise, where communities of organisms thrive, utilizing with endosymbiotic bacteria that utilize chemicals emitted from the seafloor as an energy resource, fueling these communities of organisms. And subsequently in the 1980s, seeps were discovered in the Gulf of Mexico, again with a suite of organisms that utilize endosymbiotic bacteria to provide them with an energy source, with food that these bacteria derive from the chemicals that are basically emitted from the seafloor. This is a picture of the hestionid polychaete that Jamie mentioned, the ice worm that lives in methane ice. And these are Bathymodiolus mussels that have endosymbiotic bacteria that provide them with energy. Additional tools that have come to light in the late 20th century, early 21st century include the ROVs, remotely operated vehicles, and AUVs, or autonomous underwater vehicles. Some of these vehicles have provided us with additional bottom time, but one limitation of the submersibles is that they are limited in terms of how many hours they can stay on the seafloor. Advances in technology such as these have provided us with more time on the seafloor to explore, to make collections, and have advanced our development of specific hypotheses to understand the ocean environment. Well, Jamie mentioned the exploration along the U.S. Atlantic margin. This is a map of our, basically our backyard on the East Coast, if you will. The continental slope and shelf along this region is punctuated by numerous canyons. And up until recently, the canyons were relatively undescribed, ununderstood. And there were a number of different agencies that were interested in better understanding these environments, including Bureau of Ocean Energy Management, who are keen on identifying the locations of sensitive communities that may be adversely affected by oil and gas exploration. There were NGOs and other agencies that were keen on identifying where sensitive communities would occur, and USGS, in addition, was keen on better mapping of these areas for potential marine hazards that may influence tsunamigenesis and landslides that are associated with that. I participated in a few expeditions in the 2013-2014 timeframe, and they involve utilizing the ROV, the Deep Discoverer, off the Oceanus Explorer. Specific mapping efforts that NOAA Oceanus Explorer was involved with included major mapping and survey work where they identified these acoustic anomalies, essentially they're bubble plumes being emitted from the seafloor. And at the base of these bubble plumes, we utilized the ROV to go investigate to see if there were seep environments. Ultimately, through this massive survey that they conducted, they identified at least 570 seeps that had never been mapped or identified before. So there's this rich area of potential chemosynthetic activity along the Atlantic margin within our own backyard that may be fueling and providing support for extensive seep communities. There are major questions that developed based on this mapping effort, including whether or not we would actually see the presence of methane hydrates, this methane ice that Jamie mentioned earlier. This methane ice had only previously been observed in the Gulf of Mexico in terms of the U.S. Land interests. The Gulf of Mexico has extensive hydrates as well as specific few locations along the U.S. Atlantic margin, but it hadn't been observed at these depths along the northeast coast. In addition, what was quite remarkable was the extensive mussel beds that we observed utilizing the ROV. These are chemosynthetic mussels that have endosymbiotic bacteria, as I mentioned earlier, and they were so extensive that it reminded me of rocky intertidal environments where you see mussels piled on top of mussels, piled on top of mussels. But this picture was taken at 1,500 meters depth. So deep down in the seafloor along the Atlantic coast, we see really rich diversity and abundance of organisms that we hadn't seen before. This is the first time we'd ever imaged this site before. Our explorations have continued into the Caribbean to better understand seamounts. These are undersea mountains. The location of seamounts are still being discovered throughout the world's oceans through enhanced mapping efforts. One thing I will say is that the mapping efforts still have areas to fill in. There are extensive areas even within the Caribbean that haven't been mapped at high resolution. So these features, rather not small, are still being appreciated within the environment. We're particularly interested in how seamounts play a role in possible dispersal and connection of the Atlantic and Caribbean region as far as the communities that we're focused on, deep sea corals. Through our mapping efforts, we obtained high resolution or collected high resolution maps of the Norway and Conrad seamount, and additional mapping efforts through collaborations with NOAA and University of New Hampshire and other agencies have enhanced our understanding of the location of seafloor features throughout our own extended continental shelf. So I'm finally at the point where I get to show you some movies. Through our efforts to better understand the Atlantic margin environment, we conducted extensive dives within the canyons along this region. And this first video is of a canyon that has rich paragorgia. This is the bubblegum coral that we see here. In a second, I'll play the video. It actually has my voiceover, which doesn't sound like Jacques Cousteau, but you guys can be the judge. But essentially, I am giving a narration of the importance of not only what we're seeing, but also the utilization of telepresence, the connection with the community, the shoreside community who are providing us scientific expertise, as well as the citizen scientists who are asking us insightful questions that we might not have thought of before. So if you don't mind rolling it, thanks. And then, I don't know if you can turn it up. But these are paragorgia. And to have them on hand. That's my voice. To get their input, feedback. And that's fine. I'm really thrilled to hear all of their questions that they've had too, that we don't know all the answers. We come out here with some idea of what we may find, but clearly we're always surprised. So glad you all get to enjoy it with us. Oh, it's fish. This is a barracuda.
I don't think we've seen that fish today.
That's Martha Nazinski who chimed in, and you could hear another voice. That was the pilot providing us with his observations. So it's a community on the shore side providing us with their expertise and observations, but also at sea, the pilots, the front row of guys in this case, provided us with their window into what they're seeing and their questions as well. It's a major collaboration that involves all levels of scientific knowledge. This barracuda fish is actually oriented upward with its head towards up this way vertically, and essentially that's its feeding orientation. Okay, without the audio this time, please. For the next few slides, basically the images, the video that I'll be showing have been reviewed to help us better understand the canyon environment. In this particular video, what we're seeing is a major rock face here with a variety of different organisms that have colonized the rock here, including this stony coral, as well as these yellow corals, which are called Paramuracea. It's a different species than what we saw in the earlier video. What's notable about this particular dive, this clip here, is that this coral is much larger than all these other little yellow ones. The potential explanation, this is one hypothesis that was developed while we were making these observations, is that this possibly could be the parent coral. These corals can brood their larvae and release them at a time once they've developed, and potentially this mother coral, if you will, released the corals that are around here around the same time, and that's why we see similar sizes. Now, that's a possibility. This is a hypothesis that we developed while we were making these observations, but what I want to say is we wouldn't have been able to develop that particular question or hypothesis without firsthand seeing this in front of us. And so one other aspect to note is obviously the intricate connection or synergy between the geology and the ecology of these environments. When we see these cobbles or boulders located upslope in this particular environment, where the rocks apparently seemed more stable, we tended to see more encrusting or sessile fauna, these animals that are attached to the substrate. But we'll see in a later video how that changes.
What's the scale of that? How large is that?
So in this particular video, the lasers weren't on, but when we image this with a later clip, essentially the base is around 10 centimeters, and the total distance across the coral was less than a meter in size. So basically this big. The corals, these deep sea corals are known to be long-lived. They can live several hundred years to thousands of years. And their persistence, the size of these organisms gives us an understanding of potential disturbance, such as trawling, whether trawling activity is playing a major role here. In addition, we were able to observe several examples of predator-prey interactions as well as major predation events. This is another example of something that none of us had ever seen before. If we can play this video, that would be great. This is a synaphobranchid eel, a cutthroat eel, and it's got a little fish in its mouth. This is a myctophid fish. The myctophids are midwater fish species, and this eel is known to live close to the bottom. So this observation of a deep water fish eating something from the midwater is a big deal. It clarifies the connection that we understand of between midwater species and deep water. These midwater fish organisms migrate, they conduct vertical migration to surface waters, feed on plankton, and then descend down and then provide fuel for the sea floor. So everything is connected from surface to bottom. You can see that this fish is still alive in his mouth, which is pretty remarkable. And ultimately, we get more understanding of the biomechanics of feeding, as well as the fundamental information about diets and food webs that we wouldn't have been able to get just based on the snapshots provided by looking at the stomachs. This is a stomias fish. It has a barbel on the end. I don't know if we can rewind a little bit. That fish utilizes its barbel to essentially, you can lure fish in to eat. Pardon? Yeah, we see it. Additional predation events weren't exclusive to vertebrates. We also saw some interactions with our invertebrate populations, including sea stars. If you can roll the video. What you can see in the foreground are a few different species of corals. This is a brittle star. And in the back, you see this sort of, the sea star looks like kind of dangling in the background. It's actually got its mouth averted, and it's chewing or consuming the tissue along this bamboo coral. And as we zoom in, you can take note that there are several polyps on the coral still present, and then basically kind of a clean slate down below. So it's sort of like eating like a shish kebab, I guess, if you will. Just going, yum, 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 yum. And essentially, these observations are rare. We don't get a chance to see this firsthand. And this ultimately was published by Christopher Ma from the Smithsonian Institution. We were noticing or observing sea stars throughout the dives along this expedition in the Atlantic margin, and I was one of the science leads on the seaside. I was participating in that, as you heard my voice, and I was watching or observing the chat log, and then I was also looking at the Twitter feed. And so Chris wasn't part of the expedition, but I tweeted to him, hey, can you come and watch the video and call on the conference line because we need some IDs from you. And he was able to do that immediately. Well, one, he was willing to do that. He volunteered his time. But two, he provided us with some great observations about the sea stars that none of us had the expertise to provide at the time. It was real time. And we were able to get that on record, not only for our own information and for our own scientific needs, but also for the public to gain that benefit. Additionally, you can run this one too. This is there are several examples of symbiosis, specifically with deep sea corals and animals that are found associated with them. This is a ripe area of research. There are several investigators that are interested in how these organisms, such as brittle stars, you can see the brittle stars coiled around this bubblegum coral or Paragorgia, so named because it kind of looks like pink bubble gum that I used to chew when I was 9 years old. And then the animals that we also see are something that look kind of like spiders. These are called pycnogonids. They are sea spiders. And the males are known to brood, or rather carry the eggs. And you can see that there are basically these white blobs on these pycnogonids that they're holding on to. These first-hand observations then give us some foundation to develop questions regarding these environments, informed hypotheses that we can then go back and test in the future regarding animals associated with these corals, the communities of animals that are supported by deep sea corals, as well as you can see that one coral colony supports several organisms. These are essentially like skyscrapers in the deep, providing a home to a number of different animals, the ones that you can see, and then loads of organisms that you can't see, including the microbial communities. So wiping out this colony, for instance, through fishing activities or other disturbance, has a tremendous impact on the ecosystem.
The cameras are so good that it really allows you to zoom in and see these relationships in enormous detail. I mean, I don't mean to interrupt, but it really is a huge advantage because the cameras are so wonderful.
And so, as Jamie pointed out, what you can see is that this coral, which the lasers were on at 10 centimeters in diameter, and this one coral was located on this sort of nose of a rock here. We carry on upslope and we notice that there are these essentially boulders and cobbles that have either fallen off from upslope or have fallen or located from another area. The other important feature is also how this edge of the nose, this region, looks like it's been carved out, much like in shallow or terrestrial canyons, if you will, canyons on land. So these erosional features, the deposition of rock material, the location of the corals, their proximity, their orientation on the substrate, all of these observations paint a picture of the environment in which these animals are living, how dynamic it is, the water flow, the conditions of the environment, the food availability. But we wouldn't be able to tell that without having windows onto the seafloor. I believe this is our last video that I have to show, which this came out of our work last year and the seamounts that we investigated in the Caribbean. Another example of symbioses. These are brittle stars or ophiuroids, and you can see their arms are extended around this black coral, so named because its skeleton is dark in color, a black in color. Shallow water black corals are utilized for jewelry or harvested for jewelry. In this case, we see the white or pinkish tissue covering that black coral. And the animals that are here hanging out on the coral or extending their arms, being able to utilize their position up off the seafloor to capture food. And up in the top, we saw a little chirostylid squat lobster, another crab associate with this deep sea coral. The fish that you saw swimming by was a Jeffrobarix. It's also associated with these environments. So that's a great question. With regards to different species of sea stars or different species of stars in general, we see different behaviors. With the ophiuroids, there's some indication that they're potentially the coral's maid, if you will. They help clean the surfaces of the polyps and the tissue of detritus, the material that rains down on them, keeping them clean, keeping their polyps free so that they can feed themselves. But there's some indication that there's possibly some feeding as well. So depending on the species, indicates what behavior they're exhibiting. So it really depends. The last portion of my talk, real quick, is that I think fundamentally that in order for us to advance and continue exploring in science and advancing the science that we're doing in ocean exploration, we have a major requirement to educate the next generation of scientists. The buck doesn't stop with me, it doesn't stop with Jamie. We've got to bring in a new next generation of individuals who are passionate, who are smart, and who have a keen interest in better understanding the environment around them, including the ocean. This is one example where students have been brought in to utilize telepresence, the interaction with the ship from the shore side in a way that enables them to actually conduct real research projects. This is one of the chief scientists or PIs for this project is Chris German from Woods Hole Oceanographic Institution. He has a list of other PIs involved in this project. They utilize the Nautilus to explore mud volcanoes and basically hydrothermal venting in this region. And the caveat was that none of the PIs, none of the scientists, none of the students could be on the ship at the time. They had to direct the research completely from the labs on shore. That meant that all of the scientists that were on the ship had to set aside their agendas, take off their science hat, and facilitate the science from the ship. Tremendously challenging situation, but they were able to accomplish quite a bit. The ship that they used was the Nautilus. They used the ROV Hercules that Jamie gave us images from before. These are the ship-based scientists that are helping facilitate the work, data collection, monitoring the dives, and so on. And they're helping out Chris German and his students to do their research projects from the shore side. The extent of telepresence and the utility of telepresence extends beyond our labs on shore. This is one example where we had a scientist that participated using his Wi-Fi connection on an airplane at 30,000 feet, directing the collection of a sample at around 2,000 meters depth. So this extent of the reach of telepresence and doing science at sea is far beyond anything that I could have imagined when I started doing research in 1997. This completely extends our ability to conduct ocean exploration, to advance research well beyond my wildest dreams. And just to finish up, I fundamentally believe that exploration is equal to observation. When I was in 7th grade, we learned the scientific method. The first stage of the scientific method is observation. In order to conduct or develop hypotheses, you first have to look, take a look, see what's out there. And then you can develop informed hypotheses to test, you collect your results, etc. In order for us to do our research, we have to explore. In order for me to do my studies, for my colleagues to do our work, we have to take a look. It is fundamental to what we do on an everyday basis. The work that we do is always inspiring new technologies by interacting with the engineers at sea as well as the engineers at home. We're developing new technologies to help advance the science. I will say that Jamie gave the argument that we have a ways to go regarding the technology development and our priorities. But I'm impressed with how far we've come in my short career. And ultimately, we have to keep bringing in the next generation of scientists from grade school all the way up. And at this point in time, we can do that way more easily than we ever could before. So I want to thank everyone here, definitely Jerry and Adina and Derek and everyone else who facilitated the talk here today. There were a number of people that pulled together some information for me to gather for this slide, those slides that I presented. And as I think is important to point out, there are a number of agencies, institutions, federal agencies, et cetera, that play a role in ocean exploration and facilitated the work that I presented here today. So thanks, and just if you have any questions.